Basic trigonometric equation. In this video, you will learn to solve basic trigonometric equation. An equation involving trigonometric function of an unknown angle is called the trigonometric equation. What about basic trigonometric equation? Show basic trigonometric equation in this form. Sine theta equal A, or cosine theta equal A, or tan theta equal A. That means only one trigonometric function equal, so f of theta equal A, such that f is a trigonometric ratio or function. Sine, cosine, tan, cotan, secant, cosecant. First example. Solve the equation. Sine theta equal half. To solve the equation, that means here we need to find all values of theta which make this equation true. One of you can say that theta equal half equal 30 degrees, because sine 30 degrees is half. Another one can say that theta equal 150 degrees, because sine 150 degrees equal half. Another one can say that theta equal 390 degrees, because 390 degrees and 30 degrees are coterminal, so sine 390 degrees equal half. But is there a rule? Can we find it without guessing? Yes. How can we find the solution? Sine theta, again, sine theta equal half. How can we think about the solution and how can we find it? First of all, sine here is positive. And we know that sine is positive in which quadrant? In quadrant 1 and quadrant 2. All students take calculus. So sine is positive in quadrant 1 and quadrant 2. So this is the angle theta, or maybe this is the angle. So here theta equal 30 degrees, or we can write it as pi over 6, or theta equal 150 degrees, or 5 pi over 6. But the question is, only these two solutions are the solutions of this equation? We don't have another solution? No. Why? Because here we can find coterminal angles. As we learned before, the period of sine function is 2 pi. So here, let us revise the graph, the sine function. After each 2 pi, we can repeat again. So how can we write the solution? We can write the solution as theta equal pi over 6 plus 2n pi, such that n belongs to z, or theta equal 5 pi over 6 plus 2n pi, such that n belongs to z. That means n is an integer. So theta can be pi over 6 plus 2 pi plus pi over 6 plus 4 pi plus pi over 6 minus 2 pi, and so on. another example. Cosine theta equal negative radical 2 over 2. So first, cosine here is negative. Cosine is negative in which quadrant? All students take calculus. So cosine is negative in quadrant 2 and quadrant 3. So how can we find theta here in quadrant 2 or quadrant 3? So first we need to find the reference angle here. What is the reference angle? Which angle has cosine x equal radical 2 over 2? That means x as an acute angle is 45 degrees or pi over 4. So let us find the angles of the original equation here. This is 45. So the angle here is 180 minus 45 is 135 or 3 pi over 4. And the other angle is pi plus pi over 4, 5 pi over 4. That means here theta equal 3 pi over 4 and theta equal 5 pi over 4. But how can we write general formula for the answer here for all solutions? As we know that cosine the cosine function has period to pi. Let's revise the graph again. Here 2 pi. So here 2 pi. For each 2 pi we can repeat the graph again and so on. So what are the solutions now? The solutions are 3 pi over 4 plus 2n pi such that n belongs to z here plus 2n pi such that n belongs to z. Another example. Solve the equation. Tan theta equal 2. So to solve this equation we need to find theta here. Tan is positive in which quadrant? All students take calculus, so tan is positive in quadrant 1 and quadrant 3. So here theta is equal to tan inverse of 2 and use calculator to find it. You will find it as 1.123. Now we need to find what? To find theta. As we learned before, tan, the function tan has period pi. So here theta is equal to 1.12 plus n pi such that n belongs to z. Now another example. Solve the equation. 2 sine theta minus 1 equal to 0. So first we have to isolate the trigonometric function to make it simple trigonometric equation. So plus 1 plus 1 plus 1 2 sine theta equal 1 sine theta now equal to half. As example 1, theta would be 5 over 6 or equal 5 pi over 6, and we need to write it in general form, plus 2 and pi plus 2 and pi such that n belongs to z. Another example, tan square theta minus 3 equal to 0. So first we need to isolate tan theta. So tan square theta equal to 3. That means tan theta equals positive or negative radical 3. Positive or negative radical 3. So here theta, tan theta equal radical 3 or tan theta equal negative radical 3. This is clear. And as we know that tan has period pi, so we need to find the solution in any interval, then we can add multiples of pi. So in this interval, so theta here equal pi over 3 or theta equal negative pi over 3. And as we know that the period is pi, such that n belongs to z. Another example, two cosine square theta minus 7 cosine theta plus 3 equal to 0. Here we can observe that we have here cosine square and here cosine. So if I say that x equal cosine theta, so x square is cosine square theta. Let us rewrite again the equation. 2x square minus 7x plus 3 equal to 0. We need to solve this equation by factoring. So 2x times x, and we know that 3 is 3 times 1, both are negative. So 2x minus 1 equal to 0, x minus 3 equal to 0. That means 2x, that means here x equal half or x equal to 3. Okay, let us replace x by cosine square by cosine x. So cosine theta equal half, cosine theta equal 3, and we know that 3 is invalid value, so this is rejected. Now let us continue. Cosine theta equal to half. Cosine is positive here. We know that cosine is positive in which quadrant? Quadrant A and quadrant what? 4. So we need to find the angle theta in quadrant A and quadrant 4 first. So theta equal 60 degrees or pi over 3, or theta equal 300 degrees or 5 pi over Okay, now the general solution is theta equal pi over 3. As we learned before, period of cosine is 2 pi, so plus 2n pi, or theta equal 5 pi over 3 plus 2n pi, such that n belongs to 3. That means n is an integer. Now, your turn. Solve the following equation. Cotan 4 cosine theta plus 1 equal to 3 radical 2 sine theta minus 1 equal to 0. Thank you guys. Goodbye.